All right, let's talk about curve sketching. So I would start up by saying when sketching a curve, we need to gather as much information as possible about the function and then sketch the graph. For a polynomial, we can find, um, for a polynomial, we can find one, the stationary points, two, where the curve cuts the axes, which are the intercepts, and three, the interval on which the function is increasing or decreasing. All right, so let's have a look at an example. Example 40, it says, sketch the graph of y is equal to x cubed minus x. So the first thing I'm going to do is that I'm going to start by finding the intercepts. So in particular, I'm going to try and find the x-intercepts. Now, the x-axis is the line y is equal to 0. Therefore, to find the x-intercepts, I'm going to say when y is equal to 0. So therefore, I'm going to have y, which is x cubed minus x, is equal to 0. So then let's factorize this. I'm going to get x. X into x cubed goes x squared, minus x into x is 1, and this is equal to 0. Now, if you're multiplying two things and you're getting 0, it is either the first is equal to 0, or the second, which is x squared minus 1, is equal to 0. Now, x squared minus 1 is the difference of two squares. So we're going to have x plus 1 multiplied by x minus 1 is equal to 0. So I just factorize. So it is either x is equal to 0 or x plus 1 is equal to 0 or x minus 1 is equal to 0. Therefore, it's x is equal to 0 or x is equal to minus 1. Positive 1 goes over and become negative, or x is equal to 1. All right, so we're starting. So my intercepts are, my x-intercepts are 0, 0, because the x-axis is the line y is equal to 0. So the y-coordinate is always going to, for the x-intercept is always 0. Minus 1, 0, and 1, 0. So these are my x-intercepts. All right, a careful enough analysis will also show that 0, 0 is also the y-intercept. The y-intercept is where the graph cuts the y-axis, and the y-axis is the line x is equal to 0. So if a curve passes through a point where the x-coordinate is 0, that point is the y-intercept. So 0, 0 is both the x and is both one of the x-intercept and the only y-intercept. All right, so that's for starters. All right, so let's determine the turning points. Now, in order to determine the turning points, we have to first find dy by dx. So we have y is equal to x cubed minus x, and dy by dx is equal to 3x squared. So the power comes at the front, and then you decrease the power of x by 1 minus 1. Now, the reason we have to find dy by dx is because at maximum and minimum, so at the maximum minimum turning point, dy by dx is equal to 0. So therefore, 3x squared minus 1 is equal to 0. 3x squared is equal to positive 1. Negative 1 goes over and become positive. Divide both sides by 3. And I'm going to get x squared is equal to 1 over 3. The opposite of square is square root. So therefore I can say x is equal to positive and negative 1 over root 3, or it is what? Positive and negative root 3 over 3. All right, 1 over root 3 is the same as saying root 3 over 3. All right, so I have the value of x at the turning points. All right, so let's get to the value of y. So I'm going to start up by saying when x is equal to root 3 over 3, I'm going to get what? Y is equal to root 3 over 3 cube minus root 3 over 3. All right, so this is going to become 3 root 3 over 27 minus the root of 3 over 3. This is going to become, listen, this 3 into 27 is 9. So it's root 3 over 9 minus root 3 over 3. The LCM is 9. So this is root 3 minus 3 into 9 is 3. 3 times root 3 is 3 root 3. So what we have here is this becomes minus 2 root 3 over 9. So when x is equal to root 3 over 3, y is equal to minus 2 root 3 over 9. All right, so this is one of the turning points. So let's get the other turning point. So let's write over here to sort of save some space. I'm going to say when x is equal to minus root 3 over 3, I'm going to get y is equal to minus root 3 over 3 cube. We had square here, but this should have been cube. Minus root 3 over 3. All right. So this is going to come out to be minus 3 root 3 over 27 plus root 3 over 3. Because a negative times a negative gives you a positive. 1 here, 9 here. So we're left with, we have now what? Minus root 3 over 9 plus root 3 over 3. The LCM being 9. We're going to have minus root 3 plus 3 root 3, which turns out to be positive 2 root 3 over 9. So when x is minus root 3 over 3, y is 2 root 3 over 9. So these are my turning points. One of the next thing we need to do is that we need to classify the turning points to see which one is a maximum or a minimum turning point. One way to do that is we could do the second derivative test. So we have dy by dx is equal to 3x squared minus 1. So let's find the second derivative. Therefore, d2y by dx squared is equal to 2 3s is 6, x decreases both by 1, and when you differentiate minus 1 you get 0. So next I'm going to say when x is equal to root 3 over 2, d2y by dx squared obviously is positive, because if you multiply two positive numbers you're going to get a positive. So it's greater than 0. If it's greater than 0, means that it means that what? It concaves what? You have a it concaves up, and the point root 3 over 3 minus 2 root 3 over 9 is a minimum turning point. All right. So next we're going to say when x is equal to minus root 3 over 3. So there should have been 3 here. Let's see if we can erase it without any major problem. So this should be root 3 over 3. d2y by dx squared would be equal to 6 times minus root 3 over 3, which would be a positive times a negative is a negative. So this would be less than 0. If it is less than 0, it means that this is concaving what? Down. If it's concaving down, you find that the point minus root 3 plus 2 root 3 9 is a maximum turning point. All right, so we have our intercepts and we have our turning points. I think we may be ready now to sketch our curve. All right, so on this page, what we have is this page is already populated with the information that we have gathered so far. The intercepts are 0 0, the origin. So here is an intercept. 1 0 is also an intercept. So my graph meets the x-axis at 1 0, and the graph meets the x-axis also at minus 1 0. So those are the 3 x-intercepts, and 0 0 is also the y-intercept. Now minus root 3 over 3 plus 2 root 3 over 9, which is the same as saying minus 0.6, 0.4, which would put me somewhere around here, minus 0.6, 0.4. That is a maximum turning point, and root 3 over 3 comma minus 2 root 3 over 9, which is 0.6 minus 0.4, which would put me somewhere around here. That is a minimum turning point. Now we can now therefore sketch our curve by just drawing the best curve that we can through all 3 points. All right, and that's what our curve